Quadric surfaces are like the three-dimensional version of conics. I'm going to show you several in this document, and I'm choosing values for A, B, and C so that I can just use the letters A, B, and C in all of the equations. And I'm setting some default options so that I don't have to keep typing those all the time. And so first, I want to show you an ellipsoid. You can see here the ellipsoid that I've drawn in maple. And if you look at the equation for the ellipsoid, it's like the equation of the ellipse that we learned when we were talking about conics. Only this time we've got a z coordinate added. And so if you look at the picture, it's an ellipse in all directions. The next one we want to look at is called a hyperboloid of one sheet. Now, when you see the following one, which is the hyperboloid of two sheets, you'll understand why it's called one sheet. You'll notice the entire surface. You can get from one point on the surface to another by staying on the surface. So it's all one continuous, complete surface. Now, let me show you about the equation. If you look at the equation, you notice you've got x squared, y squared, z squared, and that's equal to 1. But notice also you have a minus in one spot. In this first example, the minus is on the z squared. If you take a look at the three-dimensional graph, I'll do some here we are, if I can get it oriented right. Now here we are looking straight down the y-axis at the image in the xz plane, and you'll notice that what we see here are some hyperbolas. Now we'll twist it a little bit so we're looking straight down the x-axis. Now this is the YZ image, and you see again in the YZ image some hyperbolas, hence the term hyperboloid. So we've got hyperbolas. Now if we twist it some more so that we're looking at the XY image, we see in the XY image some ellipses. And so it's a hyperboloid in two directions. Now in this one, I've simply changed the minus sign so that it's on the y term. So again, if we look at the x and y, we should see hyperbolas. If we look at the yz's, we should see hyperbolas. But if we look at the x's and z's, we should see ellipses. And so we could twist this around and look at it from those angles. Now here in the last hyperboloid of one sheet, we see the equation of the hyperboloid that has a negative on the x squared term, and the y squared and z squared are positive. So again, if we look at the image in the xy planes parallel to the xy plane, some of them anyway, here on our image is what we would see in the XY images. And we see hyperbolas in this direction. And if we look at the image in the X's and Z's, we should see hyperbolas. So here's the XZ image looking down the y-axis, and here's our hyperbolas. And in the YZ image, we should see ellipses. So let's give it a turn so that we're looking down the x-axis in the YZ image. And there's our ellipse. Now, as you can see in this graph, we have two separate images. This is all the graph of the one equation. So we're looking at this equation, which again has x squareds, y squareds, and z squareds. But notice how many minus signs there are. 2 minus signs. That gives us two sheets. And so we got a positive on the x squared, negative on the y squared, negative on the z squared. And I'll show you the other two situations in just a moment. However, again, looking at the image in the xy plane, here's our image looking down the z-axis at the xy. And sure enough, here is the hyperbolas in that direction. We will turn it to look at the x's and z's. Let's get our z axis. So there's our x's and z's, and we have very similar looking hyperbolas in that direction. Now when we look at the YZ image, this is what we see, which is no particular image at all, just a big blob. But you'll notice there is a gap in between the two sheets where no image exists. If you look at the equation, there are values of y and z in combination with the b and c, which would give no graph whatsoever. For example, if we looked at b and c being 1, we'd have a negative y squared minus z squared equals 1. Well, you can't have two negatives that add up to 1, so there would be no graph at that point. And so we have no graph in some locations, and then in other locations you can see, again, because of the values of y, z, b, and c, we could have some ellipses. If both of these were positive and the combination of 1 and the b's and the c's came out to be larger than 1, then we would have an ellipse in that direction. So we'll look at the other hyperboloids of two sheets with the negatives on other terms. So here we have another hyperboloid of two sheets. I won't go through all of the details on that, but you can see in the equation we have a negative on the x squared term and a negative on the z squared term. So again, we have two negatives and one positive. And this final hyperboloid of two sheets you can see we've got a negative on the x squared, negative on the y squared, positive on the z squared. So again, the x, z images here would be the x, z images are hyperbolas, and the YZ images are also hyperbolas. But in the XY images, you can see we have some ellipses, and again sometimes, like here, you see the gap in the middle, we have nothing. Again, depending upon the combination of X's, Y's, A's, and B's. Now the next quadric surface we want to take a look at is referred to as the elliptic cone. You can see the image here of the cone, easily drawn using maple. And looking at the equation, it looks a lot like what we've just been doing, except that, notice here on the right side, we have an equals 0, not an equals 1. And so again, I'm going to show you the three options. Here, our equation has a negative on the z term. So again, what we see are ellipses in some directions and cones in the other direction. And here is a similar image. All I've done is switch the minus over to the y term. And here's our final elliptic cone, where I put the minus on the x squared term. And the next quadric surface we want to take a look at is called the elliptic paraboloid. Here you see the graph of the elliptic paraboloid, whose equation is given as this. Now, let me kind of show you the images that we want to focus on. First off, notice that if we take just the combination of z's and x's, kind of ignoring the y's or thinking of those as being constants, we have the z equals x squared. Well, that's going to be a parabola. So looking at our graph at the image in z's and x's, we see our parabolas. And looking at the image in z's and y's, we also see parabolas. However, if you look at the equation, if z was a constant, we'd have x squared plus y squared equals some number. So looking at the xy image, we see some ellipses. Now they're not complete in this case because of my scaling. And here's another one where I've got x in terms of y squared and z squared. And again, you should be able to see the parabolas in some directions, here, here, and it's hard to tell what that is in that direction. Maybe we can see it better from here. Nope. And the third combination has y in terms of x squareds and z squareds. And again, all of these are similar type surfaces just oriented in different directions. Now the last quadric surface we want to take a look at is the hyperbolic paraboloid. And in this one, take a look at the equation. You notice any difference in this one and the previous? If you picked out the minus sign, then well done. And so here is the hyperbolic paraboloid. And let me go through and show you this one in the ZX image. Here is the ZX image. We're looking down the y-axis, and we see parabolas, hence the parabola part of the name. And here we're looking down the z-axis at the xy image, and what do we see in the xy image? Hyperbolas, hence the name hyperbolic paraboloid. Now here's another one. Notice the similar look to it, and you can see in the equation in the xy image we have parabolas. In the xz image we have parabolas, but in the yz image we have hyperbolas. So let's get our yz image up here so we can look at our yz image. It's hard to see the hyperbolas in that image. The last one again looks very similar, a little different shape to it because of the constants that we're using. And so again, in this one, the XZ image should be where we see our hyperbola. So let's get our XZ image. There we are. And our hyperbolas are evident on this one.